A molecular formula shows the total number and kinds of atoms in a molecule. So given here we have a compound glucose, butane, and octane. All of their molecular formulas are different by the number of carbons or hydrogens or whether they have an oxygen or not. The second step is picking the structure once you know you have your molecular formula. Here we have electron dot, line bond, condensed, and skeletal. But today I will show you how to do a line bond, and this is what a line bond looks like. We have all of our carbons in the middle and hydrogens around. When it comes to placing your atoms in an organic molecule, carbon is in the center. This is because of the hybridized state and having 4 valence electrons available for bonding. This also allows multiple atoms, such as the hydrogen that you're seeing here attached to the carbon, to create complex structures. On other cases, you can find hydrogen, nitrogen, sulfur, and phosphorus groups attached where you see the hydrogen, which is the H. Here we have ethane, C2H6. I'm going to put my C's in green so you guys can know the difference between a center atom and a bonded atom and a bond. The bonds are in purple, and each center carbon needs to have 4 bonds to it, whether it's attached to a C or an H or an OH or an N, regardless of what it is. But here, our molecular formula says we have all H's attached to our 2 center carbons. So I put all of my H's. And let's review it. 2 C's and our 4 bonds to each carbon and our hydrogens. And once again, these can be OH's, N's, S, Li, F. It just depends on what our molecular formula is, and this is what ours is today. Here we have ethanol, C2H6 and an O. Oxygen, hydrogen, and carbon. Here I put my 2 C's like I did in the example previously, and I'm drawing my bonds. The difference in this one is there's an oxygen and not a hydrogen attached to all the carbons. So here I'm drawing my oxygen, and now I'll bond it with a hydrogen because there's 6 of them. So you need to make sure you include everything in the molecular formula. So now I'm going to put all my H's, and that is what makes it ethanol. Ethanol. See how I underlined it in green? That is showing that there's an alcohol attached to a carbon. An alcohol is an OH group. And here, I'm going to box the alcohol group so you guys can distinguish it from ethane, which is ANE, to ethanol. When there's an alcohol attached to a carbon, you need to change the ANE to ANOL. Here we have propane, C3H8. Put my 3 C's. I'll make my bonds and make sure all my H's are attached so that my outer shell is completely full. As you can see, all my carbons are surrounded by hydrogens. In the last example I showed you, one of the carbons ended in an OH attached to the carbon, and it changed it from ethane to ethanol. Here is propane. It just has one more C, and it has all hydrogens, so it's going to end in ANE. Here's an overview of what we did with an additional structural formula, which is called condensed. The only thing that this is showing you that's different from the molecular formula, instead of going C2H6, it's reading the structural formula from left to right. So we have 2 C's in the middle, and on the left-hand side, the C is attached to 3 H's, and on the right-hand side, the C is also attached to 3 H's. And for ethanol, from reading left to right, we also have 3 H's, so CH3. And in the middle we have a CH2, and at the end we have an OH. And this is why it went from ethane to ethanol, because there's an OH, which means alcohol, attached to the carbon. And so we change ANE to OL. And for propane, instead of eth and we have prop, we just have one more C, and so we call it propane. And if it had an OH attached to the end carbon, it would be propanol. Because